Good morning students. So in this session we are going to see another example for basic operations on signals. Okay. So let's take this question. A continuous time signal x of t is shown in below figure. Sketch and label carefully each of the following signals. So we need to plot x of t minus 1, x of 2 minus t, x of t into del of t plus 3 by 2 minus del of t minus 3 by 2 and x of 2t plus 1. Okay, this is a given signal x of t. Okay, first we'll plot x of t minus 1. Okay, so here the time shifting of original signal x of t. Okay, so we need to do the reverse operation, that is here t minus 1, so we need to add plus 1 with the time limits of x of t. Okay, so if I add plus 1 with the time limits, minus 2 plus 1 minus 1 and 2 plus 1 3, then the new limits will be minus 1 to 3. That is, the signal get shifted towards right side. We will get the delayed signal. Okay, the resultant signal will be 0. So the new limits will be minus 1 to plus 3. Okay, then we will get signal like this. Okay, and next we'll do x of 2 minus t. Okay, so x of 2 minus t we can rewrite it as x of minus t plus 2. Okay, so in this case we have to perform time reversal as well as time shifting. So as per the priority we should do time reversal first and then time shifting. Okay, so first I am going to plot x of minus t. So x of minus t we got by flipping the signal about y axis. Okay, so if I flip the signal about y axis, so whatever the portion present in the right side will get reflected towards left side. So I'll get signal like this. Okay, this is x of minus t. So after that we need to do x of minus t plus 2. So time shifting of the reverse, the signal can be obtained by adding the time limits by 2. Okay, that is we have to do the same operation. So here minus t plus 2, so we need to add plus 2. So if I add plus 2, minus 2 plus 2 0 and 2 plus 2 4, the new limits will be 0 to 4. X of minus t plus 2 or t minus 2. Okay, this minus 1. Okay, this is x of minus t plus 2. Okay, so next we'll perform x of t into del of t plus 3 by 2 minus del of t minus 3 by 2. Okay, so we know that del of t is the unit impulse. Okay, so we can draw del of t like this. And 0, its value is 1. So from del of t we can draw del of t plus 3 by 2. So it means that the signal gets shifted towards left side. Okay, so instead of 0 it's going to be at t equal to minus 3 by 2, because here t plus 3 by 2, so we need to subtract the time limit by 3 by 2. So 0 minus 3 by 2 minus 3 by 2 1. Okay, and del of t minus 3 by 2. So for t minus 3 by 2 we need to add the time limit with 3 by 2. So the signal will be shifted towards right side. Okay, this is del of t plus 3 by 2, this is del of t minus 3 by 2. Okay, so if I do del of t plus 3 by 2 minus del of t minus 3 by 2 operation, in these two signals, signal present only at t equal to minus 3 by 2 and t equal to plus 3 by 2. So rest of the places it will be 0. Okay, so at t equal to minus 3 by 2, here 1, here 0. So 1 minus 0, 1. Okay, and at t equal to plus 3 by 2, here 0 and here 1. 0 minus 1 minus 1. Okay, so this is the del of t plus 3 by 2 minus del of t minus 3 by 2. So now we need to multiply x of t with the resultant signal. Okay, so if I multiply x of t with the signal, so in the signal del of t plus 3 by 2 minus del of t minus 3 by 2, signal present only at t equal to minus 3 by 2 and t equal to plus 3 by 2. So it is enough if we multiply the amplitudes of x of t and this del of t plus 3 by 2, del of minus del of t minus 3 by 2 at t equal to minus 3 by 2 and t equal to plus 3 by 2. Okay, this is x of t into del of t plus 3 by 2 minus del of t minus 3 by 2. Okay, at minus 3 by 2 and at plus 3 by 2. So what is the value of the amplitude? So at minus 3 by 2 in x of t. Okay, so if you see 3 by 2 means minus 1.5. So it will be in the mid of minus, in between minus 2 to minus 1, right? So in between minus 2 to minus 1, it is an increasing function from minus 1 to 0. Okay, so minus 1.5 is the middle value. So we will get exactly half of its amplitude, that is 0 to minus 1, right? Then at t equal to minus 1.5, its amplitude value will be minus 0.5. Okay, so here minus 0.5, that is at in x of t at t equal to minus 3 by 2, its amplitude value is minus 0.5 and here it's 1. So 1 into minus 0.5 minus 0.5. Okay, and at t equal to 3 by 2 plus 3 by 2 here. So 3 by 2 means 1.5. So it's a middle of 1 to 2. Okay, so in 1 to 2 it's a decreasing function, that is the amplitude value decreased from 1 to 0. Okay, so 1.5 is the middle value between 1 to 2. Okay, so we will get amplitude value of t equal to 1.5 is 0.5. So here this value will be plus 0.5. Okay, in x of t at t equal to 3 by 2, its amplitude value is 0.5. In del of t plus 3 by 2 minus del of t minus 3 by 2, its amplitude value is minus 1. Okay, so plus 0.5 into minus 1 minus 0.5. So it's minus 0.5. So this is the resultant signal. Okay, and the last one, x of 2t plus 1. Okay, so in this case we have time scaling as well as time shifting. So as per the priority, first we will do time shifting operation and then we will do time scaling operation. So first we are going to plot x of t plus 1. Okay, so it's a time shifting of the original signal. Okay, so for the original signal we have to do the reverse operation, that is here plus 1. So we need to subtract by 1 with the limits of x of t. So if I subtract 1 means minus 2 minus 1 minus 3 and 2 minus 1 1. Then the new limits will be minus 3 to plus 1. Okay. So we'll get signal like this. Okay, this is x of t plus 1. Okay, now we are going to scale the signal x of t plus 1. That is x of 2t plus 1. Here the scaling factor is 2. Okay, for time scaling operation we need to divide the time limits by the scaling factor. Okay, so if I divide the time limits by 2, we will get here minus 3 by 2, minus 2 by 2, minus 1 and minus 1 by 2, 0 by 2, 0 and plus 1 by 2. Okay, then the new signal will be minus 3 by 2, that is minus 1.5, minus 1 and minus 1 by 2, 0 and plus 1 by 2. Okay, then the signal will be then the new signal will be like this. Okay, from minus 3 by 2 to 1 by 2. Okay, so here the scaling factor is 2. Whenever a value is greater than 1, we will get compressed signal. Okay, so if you have any doubts, you can mention it. So in the next class we will see one more example for basic operations on signals. Thank you.